given under the square root 224 to the base r equals 13 to the base r. Converting into the decimal, under the square root 2r squared plus 2r plus 4 equals r plus 3. Squaring both sides, 2r squared plus 2r plus 4 equals r squared plus 6r plus 9. Rearranging the terms, r squared minus 4r minus 5 equal to 0. It implies r equal to 5. In signed magnitude representation, MSB is dedicated for sign. If 0, 0 is a representation, it's a positive 0. Instead, if it is 1, 0, it's a negative 0. So signed magnitude representation has two zeros. Similarly, in 1's complement representation, if it is a 0, 0, implies it's a positive 0, 0, that is plus 0 decimal. If it is a 1, 1, that implies it's negative 0, 0, that implies it's a negative 0 decimal. So signed magnitude and 1's complement representations will have two zeros. Decimal number 43 is 1 0 1 0 1 1 in binary. To represent a 43 in 2's complement representation, the number is positive, so the representation is third option. The number 539 decimal can be written as 512 plus 16 plus 8 plus 2 plus 1. So the number 539 can be represented in binary 2 power 9 512, 2 power 8 2 power 7, 2 power 6 2 power 5, 2 power 4 16, 2 power 3 8, 2 power 2 4, 2 power 1 2. Options are in hexadecimal format, so let me convert into hexadecimal. 1011 is B hexadecimal, 0001 is 1 hexadecimal, 10 I can convert into 4 digit by inserting zeros, number won't change, so it's 21B hexadecimal. To represent minus 539 decimal, I should convert this bit pattern into 2's complement form, or equivalently I can convert the hexadecimal into 16's complement. 16's complement is nothing but 15's complement plus 1. 15's complement is r minus 1's complement plus 1 will give me r's complement, or 16's complement. So to identify 15's complement, I should subtract individual digits from f. F is 15, b is 11, 15 minus 11 is 4, 15 minus 1 is 14, that is E hexadecimal. 15 minus 2 is 13, that is D hexadecimal. To convert into 16's complement, 4 plus 1 5 E D. I should add a 1 to convert into 16's complement. So DE5 is the representation of minus 539 in 2's complement. Identified binary of 539. We identified hexadecimal of 539. To represent the number in 2's complement format, we should take 2's complement of the binary pattern. Instead, we took 16's complement of the hex pattern. Then DE5 will be the right choice. The decimal equivalent of 0.25 is nothing but 1 by 4, that's equal to 1 by 2 squared, that's equal to 2 power minus 2. Hence 0.25 decimal is equivalent to 0.01 base 2. Decimal number 15 can be expressed as 11 11 base 2. To represent minus 15, we require 5 digits. I can expand by inserting a 0. To represent minus 15 in 2's complement form, I should take the 2's complement of this pattern, starting from right extreme, traveling towards left, repeating until I am observing a 1, then complementing the digits. 1 0 0 0 1 is the representation. The given number is of the form extended sign bit. So the number is actually 1011 minus 0101. So given number is minus 5. First number present in the option is minus 000 11001. 16 plus 9, so minus 25. 25 is divisible by 5. So option A is the right choice. Given 73 to the base x equals 54 to the base y. Converting into decimal equivalents, 7x plus 3 decimal equals 5y plus 4 decimal. 7x minus 5y equal to 1. If you're putting x equal to 8 and y equal to 11, 56 minus 55 is 1. Hence option, it is of the form extended sign bit. So actual number is 1010. Its negative. Its magnitude is 0110, implies minus 6. The second number is positive. Its value is 1010, that is plus 10. Hence the product is minus 60. To represent minus 60, we require n equal to 7. The number 60 can be represented as 32 plus 16 plus 8 plus 4, implies 1 1 1 1 0 0. 1 2 3 4 5 6 digits. I require n digit, so I can insert a 0 to convert into n digits. So to represent a minus 60, I should take 2's complement of this pattern, traveling from right extreme, repeating until I am observing a 1, then complementing the digits. So 1 0 0 1 0 0 is the representation. If you are extending one more sign bit, the number will remain minus 60. Extending the sign bit won't change the number. So option. The given number 1 2 3 4 5 6 base 8 can be written in binary format. 6 corresponding to 110, 5 corresponding to 101, 4 is 100, 3 is 011, 2 is 010, 1 is 001. To identify the hexadecimal equivalent, branch 4 digits at a time. 110 is E hexadecimal, 0010 is 2 hexadecimal, 0111 is 7 hexadecimal, 1010 is A hexadecimal. To convert into base 4 equivalent, we have to branch 2 digits at a time. 10 corresponding to 2, then comes 11 corresponding to 3, then 102 0 0 0 1 1 3 0 1 1 1 0 2 1 0. So 2 2 1 3 0 2 3 and A7 to E option. Using 2's complement representation, we can represent the numbers ranging from minus 2 power n minus 1 to positive 2 power n minus 1 minus. Let us convert the given numbers into equivalent binary. 6 is corresponding to 110, 5 is 101, 7 is 111. To convert into hexadecimal, we should branch 4 digits at a time. So this corresponding to F, and second 1010 corresponding to A. So option A. 34.4 multiplied by 23.4 base 8. 4 multiplied by 4 is 16 decimal. 16 decimal is 20 base 8. So I should write a 0 here, carry 2. 4 into 4 16, 16 plus 2 18. 18 decimal is 22 base 8. So I should write a 2 to carry. 4 into 3 12, 12 plus 2 14. 14 decimal is 16 base 8. So I should write 16. 3 multiplied by 4 12. 12 is equivalent to 14 base 8. So I should write a 4. 3 into 4 12 plus 1 13. 13 decimal is 15 base 8. So I should write a 5, carry 1. 3 into 3 9 plus 1 10. 10 is corresponding to 1 2 base 8. So I can write 1 2 here. 2 multiplied by 4 8. 8 decimal is 10 base 8. So I should write a 0, carry 1. 2 into 4 8 plus 1 9. 9 decimal is 11 base 8. So I should write a 1, carry 1. 2 into 3 6 plus 1 7. 7 is a valid number in base 8. Adding together, base 8 addition 0. 4 plus 2 6 is a valid number. 6 plus 5 11. I don't have a digit corresponding to 11 in base 8. So 11 minus 8 is 3, carry 1. 1 plus 1 2. 2 plus 2 4. 4 plus 1 5. 5 is a valid digit in base 8. 7 plus 1 8. I cannot write 8 as a digit in base 8 system. So 8 is nothing but 10 base 8. So I should write a 10. So 1053.60 base 8. Two numbers are added in 2's complement. 1101 plus 0100. 1 plus 0 1 0. 1 plus 1 0, carry 1. 1 plus 1 0, and they carry out 1. If carry into the sign bit and carry out of the sign bit are same, there is no overflow. So there is no overflow. And if you are getting a carry out in your 2s addition, that implies the result is positive and in normal form. So option C is right. Given numbers are in same base. So let us convert the second number given in binary into the hexadecimal number. So while converting into hexadecimal, I should branch the digit from left to right here and right to left here. So by default I will have a 0 here. So 1010 is digit A in hexadecimal. 1110 is digit E. 1100 is digit C. 101 by default I will have a 0 here. 0101 is 5 hexadecimal. So I should subtract 5CE point A from C01 2.25 hexadecimal. By default 0 here. 5 minus 0 is 5. I cannot subtract A from 2. I will borrow from next higher digits. So 1 2 minus A. 1 2 is 16 plus 2 18 decimal, minus A is 10. So I'm expecting an 8 hexadecimal. This now became 1. 1 minus E is not possible. I am borrowing from the next higher digits. 1 is nothing but 16 plus 1, that is 17. 17 minus E is 14. I will get a 3. This digit is 0. I have to carry from, take a borrow from C. So that is 1 0, that is 16. 16 minus C is 12. I'll get a 4. This digit became f. F minus 5 is 10, that is A. That is in hexadecimal. To convert into octal, we should convert into 8 is 1000, 5 is 0101, 3 is 0011, 4 is 0100, A is 1010. To convert into octal, we have to branch 3 digits at a time, left to right here, right to left here. So this will become 4, this 3 digit will become 1, and by default I will have a 0 here. 010 is 2, this will become 3, 000 is 0, 001 is 1, 101 is 5. So option A. Given under the square root 121 base r equals 11 base r. Converting into the decimal, under the square root r square plus 2r plus 1 decimal equals r plus 1 decimal. Squaring both sides, r square plus 2r plus 1 equals r square plus 2r plus. This satisfies all values of r are equal to 0, 1, 2, 3, 4, etc. But the base cannot be 0 and base cannot be 1, and I have used a 2 here, so base cannot be 2. So right choice is base can be any value, 3, 4, 5, 6, etc. So right choice is any value of r that is greater than 2. The given number 1217 base 8 can be expanded as 111, 001, 010, 001 in binary. To convert into hexadecimal, I should branch 4 digits at a time, f. So that is option B. The given number is f8, 7b hexadecimal. Multiplying by 8 is equivalent to inserting zeros to the LSB side. So the given number is 1111, 1000, 0111, 1011. So inserting 3 more zeros is equivalent to multiplying by 8. So again converting back to the actual number, 1000 is 8 hex, 1101 is D hex, 0011 is 3 hexadecimal, 1100 is C hexadecimal, and C3 D8 base 16. Extending the sign bit won't change the number. The smallest integer that can be represented by using 8-bit number is nothing but minus 2 power 8 minus 1. That's equal to minus 2 power 7. That's equal to minus 128. Given 312 base r upon 20 base r equals 13.1 base r. Converting into decimal equivalents, 3r squared plus r plus 2 upon 2r equals r plus 3 plus 1 multiplied by r power minus 1. Rearranging, 3r squared plus r plus 2 equals 2r squared plus 6r plus 2 implies r squared minus 5r equals 0, implies r multiplied by r minus 5 equals 0. R cannot be 0, implies r minus 5 equal to 0, that implies r equal to 5. Given 123 base 5 equal to x8 base y. Converting into decimal, 1 multiplied by 5 squared plus 2 multiplied by 5 power 1 plus 3 multiplied by 5 power 0 equals x multiplied by y plus 8, implies x dot y equals 30. And we have a condition here, y should be greater than x. because x is my simple and y is my base. So the possible solutions of x and y are x1 y30, x2 y15, x3 y10, x5 y6. Y should be always greater than x. I have one more restriction here, that is y should be greater than 8, and last condition is excluded. So other than my last condition, I have 1, 2, 3 possibilities. The number of possible solutions are converting into decimal. 4x plus 3 equals 8y plus 3 implies 4x equal to 8y. I have few restrictions here. X should be greater than 4 because I have used 4 as my symbol in base x. And second case, I have used y in base 8 as a symbol, so y should be less than 8. And 4x should be equal to 8y. So x, y values are 6, 3 because x should be greater than 4, so I am begin with x equal to 6, 8, 4, 10, 5, 12 and 6, 14 and 7, 16 and 8, but I have a restriction here, y should be less than 8 and x should be greater than 4, right? So I have 1, 2, 3, 4, 5 possibilities. In the given pattern, the sign bits are extended, so the number is same as 10101. It's negative. Its value is 2's complement of the pattern 1, 1, 0, 1, 0. 1011 is 11, so it's minus 11. So you should enter minus 11. Should not forget about the sign. If I'm using n digits, I can represent a negative number. If I'm using 2's complement representation, I'm able to represent a decimal equivalent from minus 2 power n minus 1 to positive 2 power n minus 1 minus 1. If I'm representing using signed magnitude representation, I can represent from minus 2 power n minus 1 to positive 2 power n minus 1 minus 1. If I am taking n equal to 2, I can represent minus 2, minus 1, 0 and a plus 1 using 2's complement representation. Similarly, for n equal to 2, I can represent from minus 1, minus 0, plus 0 and a 1. So the number of distinct integers is more here, so x minus y is 1. The number is expressed as BCA9. To identify the octal representation, let us convert into binary equivalent. 9 is nothing but 1001, A is 1010, C is 1100, B is 1011. To convert into octal, branch 3 digits at a time from right to left. So this corresponding to 1, 101 is 5, 010 is 2, 110 is 6, 011 is 3. I can insert 2 more zeros here, so that corresponding to 1. 13625 1. To represent minus 28, I require n equal to 6. So I can convert into 6 digits by inserting a 0. To represent minus 28 using 2's complement format, 2's complement of the pattern corresponding to positive 28 expressed in 6 digits. So starting from right extreme, moving towards left, repeating until I'm observing a 1, then complement individual digits. 100, 100. Either this one or this one, you can extend the sign bits, but the extension of sign bit is not proper in the fourth option. So right option is option C. The decimal equivalent of a highest number represented in signed magnitude format is 2 power n minus 1 minus 1. Because if you are using n digits, one digit dedicated for sign and remaining n minus 1 digits will decide the magnitude. So maximum magnitude is 2 power n minus 1 minus. So if y is a negative least number, then z will become x plus y, right? So its magnitude are twice of the maximum possible magnitude, that is 2 power n minus 2. To represent a 2 power n minus 2, we require at least n plus 1 digits.